In this video, we are going to introduce you to the concept of logarithms. What is a logarithm? The exponent required on a base of a to give the value of x is written log base a of x. And we know that a will always be greater than 0 and a will not equal 1. So an example may help illustrate it. We know that the log base 2 of 8 is equal to 3. Why is that? It's because the exponent 3 is required on a base of 2 to give the value of 8. Expressed a little more simply, since 2 to the 3 equals 8, something that you already know, therefore log base 2 of 8 is equal to 3. So it's important for a good math student to be bilingual and to be able to state that same true equation in two different ways. So the inverse of the exponential function y equals a to the x is, as we know, the function x equals a to the y. For instance, that first sentence, just imagine I said to you, you're given this function like you learned in grade 11, and I said, state the inverse. And you would say to me, okay, well, that's easy. The inverse is just switching x with y. And you'd say the inverse is x equals a to the y. And I'd say, yeah, okay, you're right. And then I say to you, but I would like you to isolate the y. Well, now, how do you isolate this y when it's up there? The way you do it is through logarithms. To isolate that y, you say y is equal to log base a of x. So the base of the exponent, notice this a, the a is the base of that exponent. Well, it's also the base of the logarithm. And so again, to be a good mathematician, you've got to be able to state that same equation two different ways. So as written in red at the bottom of your screen, the inverse of y equals a to the x is y equals log base a of x, where a doesn't equal 0, or sorry, a is greater than 0 and doesn't equal 1. And just know that it is a function. It will pass the vertical line test, the logarithmic function. Now here there's a quick discussion about why a is always greater than 0 and a doesn't equal 1 in the expression y equals log base a of x. If you want to screenshot this screen and save it, you can and read it over. But basically what we're saying here is that base of that exponent right there, that a, has to be positive and won't equal 1. Okay, so let's explore this logarithmic function just a little bit more. And recalling that the logarithmic function is the inverse of an exponential function, as we just said, let's look at an exponential function that we're familiar with, specifically y equals 2 to the x. Okay, the function y equals 2 to the x is something that we did a lot of in grade 11, and it looks like this. Now, we've just said that the logarithmic function is the inverse of the exponential function. So one way of graphing the logarithmic function would be to simply switch the x coordinates and y coordinates of the, one way of graphing the logarithmic function is just to switch the x and y coordinates of the exponential function. So we've got the x and y coordinates of the exponential function right there. We can make a new table of values where all we're doing is switching them. So negative 3 comma 1/8 becomes 1/8 comma negative 3. Negative 2 comma 1/4 becomes 1/4 comma negative 2. And then we're plotting these points in the second table, and we're graphing the blue curve. So the black curve, the first one we drew, is y equal 2 to the x. The inverse of that is y equal log base 2 of x. Okay? Now, you're going to notice so far that we've always put a base with the word log. So we put this base in the place of a subscript. So for instance, when we said 2 to the 3 is equal to 8, we said therefore that means 3 is log base 2 of 8. There's always this base here whenever we write a log. Sometimes you'll see the word log written without a base. So you might see something like this, log of 1,000. When you see it written without a base, the base is 10. So if you see log base 10 of 1,000, think of it this way. Log base 10 of 1,000 is equal to x. Well, rearranging this to put it in the exponential form, as you're going to become really good at doing, would mean 10 to the x is equal to 1,000. And then we'd be able to solve that. You can tell just by observation that x would be 3. And the reason is because 10 to the 3 is 1,000. So since 10 to the 3 is 1,000, therefore log base 10 of 1,000 is 3. So if we're asked what is the log of 1,000, that means log base 10 of 1,000. And as we've just established, the answer would be 3. Okay, so that you can see here, we're just moving items back and forth, but you got to know what places they go in. And then a lot of times the math is relatively simple once you know how to move the pieces around. So here's an example. Let's write this equation in logarithmic form. 3 to the 5 is equal to 243. That's a true exponential statement. To write that exact same equation, but in logarithmic form, we would say log base 3 of 243 is equal to 5. In other words, this is saying, what exponent do I put on 3 to give an answer of 243? The answer is 5. Now, what if we give the logarithmic equation c equals log base e of d? Well, that would be like saying when we have a base of e and we raise it to the exponent of c, the answer is d. E to the c equals d. Okay, so that's how we move the pieces around. Let's write the equation of the inverse of the function y equals 7 to the x in both exponential form and in logarithmic form. Well, to do it in exponential form is really easy. If I give you the function y equals 7 to the x, the inverse in exponential form, just literally switch the x with the y, and that would be your answer. But if I ask you now that you've given me this answer as the inverse, if I say to you, state the same equation, but state it as a logarithmic equation, then you would say y is equal to the log base 7. Base of the exponent is base of the log of x. And that's what we've written here. Okay, so to some extent, there isn't really a lot of understanding that you need to do here. You just need to become adept at putting the pieces where they belong. What if you're asked to evaluate the log base 6 of 216? Well, we can say the log base 6 of 216 is 3 because 6 to the 3 is equal to 216. So when you see this written right here, we're saying to you 6 to what exponent is equal to 216? Well, since 6 to the 3 is equal to 216, therefore the log base 6 of 216 is 3. Okay, hopefully you're starting to see the thinking that goes into this. And that is the end of your introduction to logarithms.